So let's go ahead and go over integrating using long division. Doesn't look like this problem has long division in it, but I mean, there's no way we can substitute our way around this one right away. I mean, you could look at this x plus 2. Can't make ux plus 2 because its derivative is 1, won't cancel at the top. 2x plus 1 ain't going to cancel with the bottom. So we're kind of stuck with trying to figure out another method. So these are all very situational, and you always get the question, Mr. Anderholt, when do we know to use these different things? I'm going to tell you, it just kind of comes more and more, and I know you don't want to hear it, but with practices. You do more and more of these, you're like, oh, easy, I remember this. And I would say this is a more obvious case for the polynomial division, but this one not so obvious. Just like when we get to this next lesson, this one's also kind of, you may be able to figure this one out too when seeing it, but it's just going to come with practice, guys. So let's go over this. We're going to go back to polynomial long division real quick. So what I'm going to do is the numerator divided by the denominator and see if we can change the form of this function a little bit, and maybe just maybe by changing the form it will work out. I've done this before. I've been in your situation before, so don't get upset with me. You signed up for the class, and I'm going to tell you, sometimes you're going to try things and they're not going to work out. And a lot of times that's when you're going to learn the most. So, doing the division here, x times 2 will give us the 2x. So I distribute that to both of these, and then I'll use subtraction. I'm going to keep the sign away, actually. If it's positive, I don't put a sign. If it's negative, I do. So subtracting, we'll get a negative 1. Oh, I copied this down wrong. All of my ranting. This is an x plus 2 here. So that's going to be a 4, actually. Minus 4. So then a remainder of negative 3. So what do you do with the remainder? You put it over the divisor x plus 2. So that's equivalent to this here. So I can split this integral up. And so just going to integrate the 2, and this one's separate, brought the 3 out to the front. So in this situation, we know that's just going to be a 2x. Might as well take care of that, so that way that's done. Right, integral signs, they sometimes look great, other times not so much. So that's 2x. So let's figure out what's going on here. It's going to be minus 3 times something, right? But I'm going to leave that negative 3 for now. So I'm going to do a u substitution. I'm picturing u substitution because if I have 1 over u, that's going to go as natural log. But currently you can't just do natural log of x plus 2. We technically have to run it through a u substitution. Got to make it match. I'm telling you, it has to match one of these formulas here. So I'm going to make it match formula 3. du equals dx. So this one's kind of nice. And it's not a definite integral, just like we were doing in the last video. Sometimes we get used to those different things and just want to do that for everything. It's not a definite integral, so remember the definite integral, we change the bounds, and then we don't have to plug u back in. Since it's indefinite, we are going to have to plug our u back in. So natural log of u plus c. And remember, u is just going to be the x plus 2. And that's going to be your answer. So that's the idea there. You're just going to do long division. We're going to do the same thing in this problem. just long division's a little bit longer. So we're doing it just to change the form so it's something we can integrate. Something that we can get, you know, so it looks like one of those formulas on that list that I was showing you. And yes, they're just all special cases that math teachers and stuff have done in the past and want you guys to know for some reason. So here, x times 2x squared will work to get us 2x squared minus 4x, 2x cubed minus 4x squared. And then subtract, since it's a negative, I put the sign because then I just change that to a positive. And that's going to give me x squared minus 3x plus 2. And then x times x is going to be x squared. Minus 2x. So subtract to get negative x plus 2. Kind of nice this doesn't have a remainder, so we don't have to really worry about that. I don't think it has a remainder. So negative 1 will be the next thing to get us negative x plus 2. Yeah, it doesn't have a remainder, so that's nice. Oh, wait. It does have a remainder. Man, spoke too soon, right? Just double checking real quick. Oh wait, no, it doesn't have a remainder. I'm sorry, been doing too many of these videos. Negative 1 times x is negative x. Negative 1 times negative 2 is a positive 2. Then in the subtracting step, there we go, no remainder, that's nice. So you're just going to do the antiderivative, 2x squared plus x minus 1. We don't have any sort of definite integral or evaluation going on, so that's just going to be 2 over 3x cubed plus x squared over 2 minus x and then plus c.